All right, I'm going to do an example here with the TI-84 calculator. So this is going to be a confidence interval. And we're just going to use the calculator function and I'll do some interpretation on it afterwards. So we have example question 1. The masses of sweets produced by a machine are normally distributed with a standard deviation of 0.5 grams. And then they tell us they've taken a sample of 50 sweets and that has a mean mass of 15.21 grams. So let's unpack what we have as far as our instructions. We're told the masses are normally distributed. Okay, that's going to matter if we have a small sample size. So let's see what the rest of it is. The standard deviation of 0.5. So this part here, this means that sigma is 0.5. How they reference it is just all masses will have a standard deviation of 0.5 when created with this machine. It's not telling us anything about the sample standard deviation. We don't know S. We don't need S. If we have sigma, that's better. All right, and then we're told a couple more things. This bit here, we have a sample of 50. This means that N is 50. And note, this is greater than or equal to 30, so we have a large sample. And the greater than or equal to 30 is only represented for quantitative values. So we have standard deviation, we have mean, that's quantitative. So n greater than 30 matters. So we don't even need to know that it's normally distributed. It's certainly good to know, but if we had a sample of, say, 25 instead, given that it was normally distributed, we could still calculate a confidence interval. All right, and the last piece of information here, we have a mean mass from the sample of 15.21. This means that X bar is 15.21. If we want to write grams, we can do that. Okay? Now, we're not going to write grams in the actual interval, but we'll know what that means. So this is all the information we have from it. So we're going to use, for our confidence interval, we have a large sample for the mean. Let's do this. Large sample for mu, we will use the z interval. We'll use a z because we have a value at least 30 or more for a mean. We'll use a z interval. Okay. Find a 99% confidence interval for mu, the mean mass of all sweets produced by the machine, corrected to 2dp. 2dp is decimal places, so we're going to do our confidence intervals with that in mind. All right, so we're going to go to the calculator on the right here. How we do this is stat, and then tests, and then we're going to do z interval. That is the calculator function we're going to use. So the stat button is just a little bit to the left of those arrow keys. We can arrow to tests, arrow left, and z interval is number 7. So we're going to go down to number 7, or you can just hit the number 7, that's fine. Or if you have a different calculator, it may not be 7, I don't know. Okay, so we are not given any data, so we're going to leave it on statistics. It's already highlighted. If it's not, then you need to arrow over, highlight stats, and hit enter. The first piece of information it wants is sigma, which is 0.5. So let's change that to 0.5. X bar is 15.21. And N in this case is 50. The C level is the confidence level we're looking for. In this case, it's 99%, so 0.99 is what we want to put there. And that's all the information you should need. This is how we use the calculator. So we'll hit calculate, and we have an interval up there. Now they want 2 decimal places. So let's do that. Go back to blue maybe. Our interval is 15.028 means 0.03, and then 15.392 is just 15.39. Let's draw that a little better. There we go. This is our interval. So the question, part A, just asked for the interval. We have the interval right there. Let's see. Part B. The manufacturer of the machine claims that it produces sweets with a mean mass of 15 grams. So they're saying that the mean is 15. So now we have to read this a couple ways. It seems to me by everything that's involved with this problem that we're looking for specifically this, that the mean is greater than or equal to 15. That's what they're telling us. They're not telling us that the mean is just 15. Think about if you're buying a can of pop. They say it's 8 ounces, whatever it is. They say 8. Well, you're not going to have a problem if it comes in at 8.1 ounces, but you might have a problem if it comes in at 7.7 ounces. So if they say 8 ounces, it's got to be 8 ounces or more is what they actually mean. So we're looking for the mean is at least 15 grams for this. Well, let's take a look at our interval. This entire interval is above 15, which means that there's an infinitesimal chance that they're going to be able to get a sweet that has less than 15. So we have evidence, have sufficient evidence to determine that the machine produces sweets of at least 15 grams since, let's scroll down a little bit, since the entire interval is above 15. So our interval goes from 15.03 to 15.39. If we drew that on, here's 15, 15.1, 15.2, 15.3, 15.4, and so forth, we could highlight the confidence interval going from about there. That'll be our confidence interval. That entire confidence interval is above the number of 15, so you're going to get a mean mass of at least 15. And again, they're looking at the mean, not every individual one. There could certainly be one that's below 15. From the previous chapters, we know that it's easier for a single thing to be below than the entire mean to be below that value. So that's what we have, and that's a good example of how you use the calculator to do a confidence interval for a mean.